Hello everybody and welcome to the TDP YouTube channel.
Hi guys, I'm Robbie from TDP. Welcome back. We are today going to do module 2 of how to PCLink. So in module 2 we're going to discuss sensor setups, what are analog temperature sensors, what are analog voltage sensors, what are GP sensors, what are digital input sensors, and briefly the difference between the input method of G4x and G4+. So give me a sec, we'll switch our screens and we'll get going here. Okay, so here we are in G4x. I am just going to open our demo map just to make sure that everything is easy to work on. So we have a base map loaded, unpopulated mainly. And so today we want to talk about sensors. So what are sensors? Well, sensors are any input device that gives the ECU information about some way the engine is performing in, whether it be temperature, pressure, throttle position, or an input from a camshaft sensor or something like that. So how do you set up a sensor? Well, most sensors are of an analog nature, so they will be here under the analog inputs. Now in G4x we have this difference where you don't get a list of the input pins in front of you, you get a list of the sensors. Okay, if you are from G4+, you're going to notice that, oh, where are my input pins? Well, they're here. Now you can click on them, but you can't do anything with them. But you can see them, but it's a start. So we're going to give you an example of an analog temperature sensor and how you'd set it. So a very common analog temperature sensor that every vehicle will have is going to be the engine coolant temperature. So if you click on the engine coolant temperature here, it will say source none. So you say, okay, well, that needs to be a source. So you look at your wiring diagram, see what way it's wired, and it's wired to AN temp 1. So you click AN temp 1. So AN temp 1 comes up, and now down here in your input pin, it has been assigned. You can see that it's now assigned. So it's not that much different from G4+ really. So then you have your analog temperature, error low and error high. These are to indicate whether there is a problem with the sensor. So on an analog temperature sensor, if the voltage goes below 0.05, generally that means that the sensor is completely shorted out to ground. It will go to 0 volts, then the ECU will go, it's below the low value, and we'll put it in error. Conversely to that, the high value is 4.95. It's on a 5 volt pull up. So if it gets to 5 volts, it will assume that it's either disconnected or that the signal wires are broken. So it's important to have them set up. If you know the characteristics of your sensor, always set these a tiny bit towards the very end of each sensor calibration, and you'll get a bit more accuracy if the sensor stops at 0.5 of a volt. Well, set it at 0.4 of a volt. Will just give you more failure mode. Okay, so next thing is pull-up resistors. Some ECUs don't have this switchable. In Link we have this switchable on most Link models. So you have a choice of 1 kilo ohm to 5 volts or 10 kilo ohm to 5 volts or off. Most of the time it's 1 kilo ohm unless the sensor says otherwise. Off is basically used if you are piggybacking the ECU onto OE system and you were letting the OE system provide the pull-up and you didn't want to alter the OE system's resolution or influence it. So if you put it to off, then you can just measure the voltage return on the OE wire and calibrate it accordingly. Error value. For a coolant temperature sensor, it's really important that this is set higher than your trigger for your rad fan. So if your coolant temperature sensor fails, your engine is hot, the rad fan will come on. So if your rad fan set at 85 and the hysteresis is 3, set this at 90. The last thing is calibration. Okay, so most of the calibrations are already here. Link have provided a good amount of them. A lot of sensors follow this standard Bosch curve. Where possible, always check what the sensor is, what curve it should be, because the last thing you want is an incorrect temperature into the engine, telling you your engine's not as hot as it is, and then you fry it. So pretty important to get that right. Okay, so they're all gone red here. Seen this before. If you watched the previous video, you'll see that that's because they're not saved. We're gonna go save as down here, and I'm just gonna call it edited to. That'll do fine. And because we now save it, they go white. So now they're saved. So that's an example of a analog temperature input. Now we're going to look at an analog voltage input. So common one would be the throttle position sensor, I suppose. So give it a source, analog voltage 2. Again, error high and low values, same principle. If your minimum TPS is only 0.5 of a volt, you could set that at 0.3. If your maximum TPS is 4.2, you could set that at 4.4. And once it goes over that or under that, the ECU is going to know, oh, there's something very, very wrong. I'm going to immediately put it to the error value, which is down here. You could put it to whatever you want, either 0, but with throttle we suggest either 0 or 100, so that it will either shut the engine down or to idle, or it will give it enough fuel to be at least too rich for your throttle position, so you won't melt it if your throttle is your main load source. So put it at 100, save the file, they go white. So that's an example of a voltage input. Other voltage inputs would be a pressure, like oil pressure or map. So just do map really quickly. So map, again, select your source, low and high error value, your error value that it should be if it fails, normally the maximum of the sensor. So we'll say 300, sorry, it's a 4-bar sensor there. We'll change it to a 3-bar sensor, 300 kPa, link 3-bar. There is a filter now on map in G4x in case you have a really pulsy camshaft at low RPM. But be aware, if you use it at high setting, it might dull the response slightly in other areas of the map for Excel fuel and stuff. Map calibration, if you click that when you're online, click yes, it will do a map calibration when the engine's not running and compare the at rest value of the sensor to the barometric pressure sensor and negate any voltage drift caused by the wiring in the car, and that should be done reasonably regularly if you're messing around with your car and your wiring. Okay, so that's a pressure sensor. Another pressure sensor is just oil pressure, but we're not going to get into all these sensors, so it's just going to be very mundane. One other thing is you lambda sensors. The other thing in lambda is you have a choice really, because you can take it in over CAN now. And actually, there are CAN analogs for the other sensors. We'll do this in another video when we talk about CAN bus, and we'll talk about lambda in another video as well. But as you can see now, we've started to calibrate the input pin setup here in a more meaningful way. And if you need to access a custom calibration table, they're in this folder here. We're not talking about them today. We will do more in depth on how to calibrate a sensor if you have no data for it at another stage. GP inputs. So if you want to put in something that's not on this predefined list, you go to GP input. You have a choice of rotary switches now, which is nice, temperatures, pressures, and just general analogs. These are for sensors like that you want to control auxiliary tables for trimming maps and other things. They're easy to use, same procedure. The only difference is you can give them a name. So, test sensor. Okay, and if we give it a calibration of a cal table, then, which you'll have to do for these, because these are GPs and it doesn't know where to get any calibration from. If you selected GP pressure, it would have gone to the pressure list of known pressure sensors. If you went to temperature, list of known temperature sensors. So here we're in a GP analog. It'll go to a calibration table So you can click on Cal 1. I'll give you a real quick look through that, even though I said I wouldn't. But it just makes this a bit more complete. Go to Calibration 1. And in Cal 1, you have a choice of units, voltage or ohms. Normally it's voltage, output units. So you can have temperature, pressure, lambda, percentage airflow, distance, volume, whatever you want. So you could say volume actually, because you could be a fuel tank sensor. And then your calibration table can be populated. Your calibration table can be then populated from 0 to 5 volts. Let's learn how to type, would be useful sometimes. And then you can say at 5 volts we've got 45 liters, and at 4 volts we've got 10 liters, and by using the shortcut key, and then if any of you are familiar, Shift H is interpolate horizontal. It gives you that. That is another example of a GP input. Okay, now if we go back now, close our GP input, you will also see that the GP input now has come to input tables. So we've covered our analog inputs. I think the next sensor I want to talk about is a digital sensor. So it's a switched sensor, but it's still a sensor if it does an item that controls something. A good example of this clutch switch, pick a DI. Well, you can pick any of these, but at the moment we're just talking about physical pins. Pick a DI that it's on. Does it need a pull-up resistor? In other words, is the switch switching to ground, or is it switching to 12 volts, or what is it doing? But if it's switching to ground, so in other words, when you press the clutch, the switch just connects to the chassis, I would put pull-up resistors on. If you want the sensor to say the clutch is pressed when it's on the ground, you would say low side. If you want it to say the clutch is off when the clutch is up, you can say high side. And the latch you would definitely leave off. Latches will need a pulse on and a pulse off to make it work. Okay, so there's an example of a digital input. There are other digital inputs that are needed over time. Again, you can see your input pins here. Digital inputs are also used for extra camshaft position inputs for multicam, VVT and stuff like that. We'll discuss that in another episode. I just want to show you now, literally, you've seen basically the analog input and the digital inputs here. You've seen the GP inputs. So I just want to pop into G4 Plus. So here we are in G4 Plus. Doesn't look a whole lot different, but if I click analog, you will see that in G4 Plus, you just get a list of the analog voltages, analog temperatures, and we have to click on them and tell them what they are. There are the functions, predefined functions, map, and here's GP. We do this way, and the calibration is exactly the same. But the one thing is that's cool in G4X is that you can do it by actual sensor, and then afterwards you can have a look at your pins. So we find that the new G4 Plus, even though it's intimidating for some people, actually is an awful lot more intuitive, than G4 Plus. So one thing people will say, oh, I've got a blocked pin. Well, if you go to input pins and you go analog temperature now, and you don't like analog temperature on AN1, you actually can click here on the function and it will drive you to the function. You can't click on it if it's not populated, but if it is populated already, you want to change it, you can just click here in your input pin and go, oh, analog voltage 2 is actually the map sensor or the oil pressure sensor. Click on it, bring you here, and you can basically turn it off and then go to wherever you want to change it to, and say oil pressure now is on analog voltage 2. Okay, so really that's exactly it. That's how you use the main sensors in G4. There is nothing really difficult. It's very intuitive for setup. It's got a lot of calibrations pre-done, and we think that you're going to find it easy to use. So that's it for today. Thank you very much.
If you liked this video and would like to see more like it, please press the subscribe button.